A journey from calculus to kinetic reality. The anatomy of a spiraling flow. This investigation into helical fluid dynamics follows a structured progression, transforming abstract physical principles into a vivid, interactive exploration of a fluid moving like a controlled, rising whirlpool. The path of the spiraling fluid. The core of the motion is defined as a steady helical flow. In this state, fluid particles do not simply move in a circle. They rotate around a central axis while simultaneously translating upward. Because the fluid is incompressible, its volume remains perfectly constant throughout this journey. Even as a small cube of fluid is stretched or tilted by the spiral path, it never loses or gains mass, maintaining its physical integrity from start to finish. Interaction with the boundaries. To understand how this fluid interacts with its environment, the study examines how much mass passes through three distinct virtual gates. The top lid. Fluid flows consistently and uniformly through the top of the cylinder as it ascends. The outer wall. Despite the rapid spinning, the fluid never actually crosses the side walls. It remains perfectly contained within the cylindrical boundary, proving the flow is strictly internal. The vertical slice. If you were to take a radial slice from the center to the edge, you would see the rotational swirl passing through that plane, with the intensity of the movement increasing the further you get from the center. The essence of internal spin. The most defining characteristic of this movement is rigid body rotation. This means the fluid elements spin around their own centers as they travel. This internal spin, or vorticity, is constant and points straight up. Unlike a chaotic storm, this flow is stable and predictable, acting as a single cohesive unit as it spirals toward the top. Bridging theory and vision. The Total Mass Flux project uses high-fidelity simulations to prove these points. By tracking individual fluid elements, the visual tools show that while the fluid might shear and deform, its total volume remains unchanged. These interactive demos allow observers to toggle between different surfaces, transforming mathematical derivations into a clear, kinetic reality of how mass moves through space.